Now we'll take a look at exponents. We're sure you're pretty familiar with your exponent rules, but we want to refresh your mind because there are a couple that have proved to be tripping points for students. Now, rule number 1, a to the m equals a times itself m number of times. This one's pretty simple. It's just a times itself the appropriate number of times. Now, notice I'm using a and I'm using m here. The SAT loves to give you variables other than x and y because they know you're used to seeing x and y. They like to give you variables like a and m and p and t, anything to bother you. Okay, rule number 2. A to the negative m equals 1 over a to the m. Anytime you have a negative exponent, that means there's an exponent in the denominator. Concomitantly, if you see an exponent in the denominator, it's illustrated with a negative exponent. Now, number 3 is the most important exponent rule we're going to go over. And I know I didn't do anything to that. A to the m plus a to the n equals a to the m plus a to the n. This is frequently a tripping spot. Remember, if you add or subtract the same number or variable with different exponents, you can't do anything to the exponents. All you can do is factor a little bit. The reason for the confusion is rule number 4. A to the m times a to the n equals a to the m plus n. If you multiply the same number or variable with different exponents, you add the exponents. Now, rule number 5, a to the m raised to the power of n is a to the m times n. The only time you multiply exponents is when you're raising a power to a power. And rule number 6, if we divide by exponents, you're subtracting. So a to the m divided by a to the n equals a to the m minus n. Taking a look at inequalities, they'll usually ask for 2 types. This first one we'll call a string out. It says that 3x plus 6 is greater than negative 15 but less than 30. Now, your teachers at school may teach you to separate these and work it as 2 separate inequalities, but I'm going to suggest we want to keep things simple on the SAT. So let's keep it as one inequality. And remember that if you do something to one segment of it, you must do it to all segments. First, we're going to isolate that 3x. So let's subtract 6 from each portion. Well, that'll give us negative 21 is less than 3x, which is less than 24. Now, if we divide through by 3, we're left with x is greater than negative 7, but less than 8. This second feature of an inequality is actually more common. Actually, when you see inequalities on the SAT, your antenna needs to go up, and you need to start looking for a negative value. Because remember, if you multiply or divide by a negative value, it flips the inequality. For example, negative 5x plus 6 is less than 26. Subtracting 6, that gives us negative 5x is less than 20. When we divide by negative 5, it reverses the inequality. So you're left with x is greater than negative 4. Let's take a look at scientific notation. Scientific notation is really pretty simple. Shouldn't be too much of a problem. Just remember you count the number of zeros to the right of the number. So 4 times 10 to the 5th is 400,000. 7 times 10 to the 4th is 70,000. Now, if you're multiplying 2 terms that are represented in scientific notation, you're going to want to combine like terms. So if we've got 4 times 10 to the 6th times 7 times 10 to the 7th, combine like terms. So you're going to have 4 times 7, and you're multiplying the same number of variable with different exponents, so you add the exponents, so you get 10 to the 13th, which gives you 28 times 10 to the 13th. But remember, with scientific notation, you have to take it to 1 decimal place. And we're moving 1 number to the left, so that becomes 2.8 times 10 to the 14th. Intersecting lines from vertical angles, and vertical angles are equal. And remember that supplemental angles share a line and total 180 degrees. Knowing how to determine the x and y intercepts is going to help you on several fronts on the SAT. First, on occasion they do want to know what the x-intercept is or the y-intercept. But it's also a way of working with some of the functions, some of the graphs that they give you. Now remember, to determine the x and y-intercept, you have to think a little bit crossways. If you set x equal to 0 and y equal to 0, you'll find the x and y-intercepts. But if you set x equal to 0, that gives you the y-intercept. That shows you where the x value is 0. That's where the line is going to cross the y-axis. Concomitantly, when you set y equal to 0, that shows you where the line is going to cross the x-axis. It's a little bit backwards, but once you realize it's that way, it's easy to remember. Occasionally they may ask you for the surface area of a cube. Remember that the area of a cube is side squared. You have 6 faces to a cube. So the surface area of a cube is 6s squared. You must remember the order of operations. Remember the acronym PEMDAS. Please excuse my dear Aunt Sally. This stands for do all the work around the parentheses, evaluate the exponents, you multiply, divide left to right, you add, subtract left to right. PEMDAS, or please excuse my dear Aunt Sally. They'll give you a pretty simple problem like this. At first glance it looks easy, but you've got to remember there's a trick to it. You've got to remember to round up. Okay, in this case, if it takes 1 gallon to paint 8 square feet of wall, how many gallons are needed to paint 4 walls, each measuring 11 by 9 feet? Okay, your first step, get the numbers out of the words. And getting the numbers out of the words, each wall is 11 by 9, so each wall is 99 square feet. We've got 4 walls, so 99 times 4 is 396. We want to know how many 8s are in there. So 396 divided by 8 gives us 49.5. Okay, remember, if you've got half a gallon, you've got to have a whole gallon to have that half. So you've got to, in this case, round up. You've got to have 50 gallons.